Pages 5 through 8 of the fractions tome. Radicals. So we have a radical right here. The number in the front in red, that 5, is the coefficient of the radical. The number inside the check mark part of the radical is the index. And then the 7 is the radicand, also known as the base. And then if we had exponent here, let's just say it was a 1, this would be the power. If there's no index shown, it's implied to be a 2. If there's no power shown, it's implied to be a 1. Like radicals have the same radicand and index. Let's look at this. So let's fill out our perfect squares and perfect cubes first. So the square root of -1 is I, square root of 4 is 2, square root of 9 is 3, square root of 25 is 5, and the square root of 49 is 7. For your cubes, cube roots, we have the cube root of -1 is -1, the cube root of 8 is 2, the cube root of 27 is 3, the cube root of 125 is 5, and the cube root of 343 is 7. So using these, let's do some of these problems on this page. So let's start with this one. The square root of 25x to the 10th power. You will find the square root of 25 and the square root of x to the 10th separately. So the square root of 25 is a perfect square. It's 5. The square root of x to the 10th can be rewritten as a rational exponent. We have a 2 down there because the index is a 2 because there's nothing there. 10 divided by 2, it's 5. So we have x to the 5th power right here. And then just put those together. 5 times x to the 5th power. And that's your reduced radical. Let's look at square root of 98. Now the square root of 98, we could try to pull out each of these. There's no negative, so we can't pull that out. Let's try the next number. 98 divided by 4. That's a decimal, so we're going to reset it and try another number. 98 divided by 9. It's a decimal, reset it and try the next number. 98 divided by 25. It's a decimal, reset it and try it again with 49. And that gives you 2. So 98 is 49 times 2. The square root of 49 is 7, and the square root of 2 cannot be reduced, so that's your simplified expression. 7 square root 2. And then we have the square root of x to the 7th power. We're going to rewrite it as a rational exponent, and then find the remainder using long division. 2 goes into 7 3 times. 3 times 2 is 6. Subtract that, you get a remainder of 1. So we can rewrite this as x to the 3rd power. That 3 goes on the outside from the quotient. And then we have square root of x to the 1st power. The remainder goes on the inside. Okay, let's do one more together on this page. We have the cube root of 24x to the 15th power. Simplify the number and the variable separately. The cube root of 24. So now we're looking at these numbers. There's no negative, so we can skip that and go to the 8. 24 divided by 8, and that's 3. So we have the cube root of 8 times the cube root of 3. The cube root of 8 is 2. So we have 2 cube root 3. Let's rewrite this variable as a rational exponent. So we have x to the 15 over 3 power. 15 divided by 3 is 5. So we have x to the 5th power. Put these together. So there you have 2x to the 5th power times the cube root of 3. And that's your simplified expression. Let's move on to the next page. Page 7, adding and subtracting radicals. You want to simplify the radicals first if you need to, and then make sure to refer back to the previous page to see what numbers to try to divide out. So 2 square root 9. The square root of 9 is a perfect square. It's 3. So we have 2 times 3. And that gives you 6. Okay, let's look at number 3. 5 square root 8 plus 7 square root 2. The square root of 8 can be simplified. The square root of 8 is the same thing as 4 times 2. We have the square root of 4 times the square root of 2. So then we have 5 times 2 times square root 2. This square root 4 turned into a 2. And then we have plus 7 square root 2. So 5 times 2 is 10. So we have 10 square root 2 plus 7 square root 2. These are like radicals now, so we can add them together to get 17 square root 2. Let's do another one. Let's do number 6. The square root of 500. Well, we also know that the square root of 100 is 10. And that actually is 2 perfect squares together that we have on our previous page. So 500 is the square root of 100 times the square root of 5. 125 is the square root of 25 times the square root of 5. And then 20 is the square root of 4 times the square root of 5. Okay, let's keep simplifying. The square root of 100 is 10, so we have 10 square root 5. We have minus square root 25 is 5, square root 5. And then plus 3 times 2 times the square root of 5. So 10 square root 5 minus 5 square root 5 is 5 square root 5. And then 3 times 2 is 6, so we have 6 square root 5. We have the like square roots here of 5, so we can add these together to get 11 square root 5. Let's go ahead and move on to page 8. This one we're multiplying square roots. Multiply each square root expression and simplify. So I have some of the examples already filled out for you on the side. Let's do one other together. So let's do the last one. 3 plus 2 square root 5r times 2 plus square root 5r. So we want to do a box for this. So we have 3 plus 2 square root 5r on the side and 2 plus square root 5r on the top. 3 times 2 is 6, so that's the area of the first box. The area of the second box is 3 times square root 5r, so we have plus 3 square root 5r. This will be 2 times 2, that's 4, so 4 square root of 5r. And then 2 times 1 is 2. Square root of 5r times square root of 5r is 5r. So we're going to go ahead and combine like terms. These two terms are like, so we have 7 square root 5r. So we have 6 plus 7 square root 5r plus 2 times 5r is 10r. If we were to put this in standard form, we would just reverse the order with the 6 and the 10r. So go ahead and finish the rest of the questions on this page and then move on to the next page.